Hello dear students, in previous session we were discussing some NEET aspect as well as CET aspect related to electrostatic potential. So now we would like to extend about that capacitance. So what is that capacitance? So capacitance is nothing but it is a device which can use to store the charges. So related to that capacitance, I will send certain kind of synopsis into the group. So just you follow those kind of synopsis and try to solve the numericals related to capacitance. So I will solve a certain kind of numericals related to capacitance on certain formulas. So how to focus on remaining numericals as an assignment here. So let me focus on some numericals related to capacitance. So for example, I will read out the question here. So two conducting spheres of radius r1 and r2 are at the same potential. So here two conducting spheres are there, and these two conducting spheres having the radius r1 and r2, and these two conducting spheres having the same potential. So conducting sphere having radius r1 and r2, and they mention that so these two having the same potential, their charges are in the ratio of, so which thing I need to determine here? Charges. So they mention r1 and r2, so I need to find out that what is the relation between radius and the charge here. So in order to calculate such thing, so I will consider here, so conducting sphere, so I will consider that capacitance of a parallel plate capacitor. What is the connecting formula? C is equal to epsilon naught A divided by R or D here, where capacitance formula, so C is equal to, shall I write as a Q by V here? Q by V is equal to what? Epsilon naught A divided by R. So potentially same dimension. Then what it means here? So QV is proportional to A by R here, where A is nothing but what? Pi R square here. So Q is proportional to A by R here. So Q1 by Q2. So shall I take it as a A1? So area of means area of the circle, so that is pi r square I will consider. So here pi into r1 square divided by r1 for that second one. So second one is r2 divided by pi into r2 square. So pi term will get cancelled out here, r1 square here, r1 term getting cancelled out here, r2 is there, and here r2 square is there, one term will get cancelled out. So q1 by q2 here, so here r1 is there, so here r2 is there. So then what is the ratio of charge to the radius here? So q1 by q2 is equal to r1 by r2. It means that qv is directly proportional to radius of the sphere. As the radius of the sphere increases, so charge value is also getting increases here. So next we will solve. The capacitance of a parallel plate capacitor is 2 microfarad. So capacitance of a parallel plate capacitor is 2 microfarad here. The distance between the plate is increased 3 by 2 times, and dielectric of relative permittivity 6 is placed between them. Then the new capacitance is, initial capacitance is 6 microfarad. Now they are introducing a dielectric constant, so that dielectric constant value is 6, and the distance between the plate is increased by 3 by 2 times. So distance between the plate is increased by 3 by 2 times, means new distance is 3 by 2 times of d. Then what about the new capacitance here? So C is equal to epsilon naught A divided by D. So what is that value they mention? 2 microfarad. New capacitance after introducing a dielectric medium. As the dielectric medium you introduced between the plate of the capacitor, so its value is getting increases or decreases here. So connecting formula, C dash is equal to K into epsilon naught A divided by D dash. So capacitance is directly proportional to dielectric constant. It means that as you introduce the dielectric constant value, its capacitance value should get increases here. So let me write that value. K value is how much? 6. Epsilon naught A divided by D dash is what? 3 by 2 times of D here. So C dash is equal to 4 epsilon naught A divided by D here. Epsilon naught A divided by D. So what is the value they mentioned? 2 microfarad. So C dash is equivalent to what? 8 microfarad here. What is that C dash value here? C dash value is 8 microfarad here. So we'll look at that next one. Two small spheres of radius 12 centimeter and 6 centimeter have equal charges here. So look at the question here. One second, I will check out the camera. Okay, fine. Two spheres of radius 12 centimeter and 6 centimeters have equal charges. The ratio of the energy is, so radius value they mention. So what are that value? 12 centimeter and 16 centimeter here. And they are asked to determine that what is that energy. So U1 value and U2 value. So energy in terms of ratio here. So first I would like to determine that what is the relation between energy and that of radius. So we know the equation for energy stored in case of capacitor. So that is half of C into V square, or another formula is, so Q square divided by 2 times of C. So what is that another formula here? Q square divided by 2 times of C here. So this is the relation between, so potential, sorry, energy stored and that of charge here. So for example, here that capacitance is there. So C is equal to, shall I write it as the equation? So in case of that energy stored in a capacitor, so C is equal to epsilon naught A divided by D here. So U is inversely proportional to C. So R, I will write that. So epsilon naught A divided by dr divided by R here. So divided by R means U is proportional to R divided by, so pi R square here. So pi R square means, so pi is a constant value. So what the value I get it here? So potential energy is inversely proportional to radius. So potential energy is inversely proportional to radius means, so energy in terms of ratio, so U1 by U2. So shall I write it as a R2 by R1 here? So why? Because potential energy is inversely proportional to radius here. R2 value is how much? 16. R1 value is 12. So what is the ratio I will get it here? So 4 by 3. So did you get my point here? So look at here, they asked to determine the potential energy. So let me find out that relation between potential energy and radius. What's the answer here? Potential energy is inversely proportional to radius here. Next we will look at that fourth question. 64 identical mercury drops, each of capacity 1 microfarad, to form a bigger drop. How many identical drops are there here? 64 identical drops are there. So each 64, each value is 1 microfarad here. So each value is 1 microfarad combined to form a bigger drop. N number of identical liquid drops are there. It combines to form a bigger drop. Then capacity of the bigger drop. So what is the connecting formula having? C dash is equal to what? N to the power of 1 by 3 into C. C dash. N value is how much? 64 here. So C value is how much? 1 microfarad they mention. So 64 shall I write as a 4 cube here, whole to the power of 1 by 3 into 1 here. 1 microfarad is there. So it will get cancelled out. So 4 microfarad. So what is the capacitance of the bigger drop? I will get it here. Capacitance of the bigger drop is 4 microfarad here. Look at that next question. So just you go through synopsis first. If you remember the synopsis, then only you may solve that. You can able to solve the numericals. So just you remember that synopsis related to all topics. So just you make a separate note for that synopsis. Okay, I will read the next question. An eye drop is found floating freely between the plate of a parallel condenser. So one parallel condenser is there. So between the two plate, so one eye drop is floating here. The plate being horizontal and lower plate carrying a charge of plus q here. So that plates are arranged in a horizontal manner. Lower plate carrying a charge of plus q. Area of each plate is E. Distance between the two plates is d meters. Mass of the oil drop is m in kg. Then charge on the oil drop is. So let me find out that. For example, here two parallel plates are there. Lower plate is positively charged. So here that one oil drop is there. So that oil drop is floating between the parallel plate they mention here. So let me find out that what is the magnitude of this charge. So oil drop is floating means, so shall I write it as a F is equivalent to a E into Q here. So F is nothing but a M into G here. So E into Q. So what is the equation for electric field between two parallel plates? So that is sigma by epsilon naught into Q here. So sigma by epsilon naught into Q, where sigma is nothing but what? So sigma is nothing but a surface charge density. So sigma is equal to, shall I write it as a Q by A here. So sigma is nothing but a Q by A here. Sigma is nothing but a Q by A, epsilon naught as it is here, into Q, where small q represents the charge on the oil drop, where capital Q represents what? Capital Q represents the charge on the plate here. Let me find out that charge on the drop here, oil drop, M into G, epsilon naught A divided by Q here. So what is the answer here? M into G, epsilon naught A divided by Q is the answer here. So first I will consider that force here, relation between field and force. F is equal to E into Q, where F is equal to M into G, where E in the sense electric field between the plates. So what is the value here? Sigma by epsilon naught. So wherever sigma is there, that is surface charge density, I will write it as a Q by A here. Next one. The reason between two plates of a parallel plate capacitor is filled with the dielectric slab of different dielectric constant as shown in the figure. So for example, here they mention one parallel plate here. So in case of that parallel plate, they are going to be filled with the dielectric medium of different material. So dielectric medium of different material here. So this is one dielectric medium and this is other dielectric medium. So it is placed in such a manner. So this dielectric constant value is 2 and this dielectric constant value is 3. Find the capacity if the capacity of the capacitor with air between the plate is 20 millifarad. So 20 millifarad. So instead of the dielectric medium, if air medium is present, means its value is 20 millifarad. So here they introduce two dielectric constant in this fashion. So then what about the equation for that capacitance? So C is equal to C naught K1 plus of K2 divided by 2. So already in regular classes we look at these kind of synopsis here. So just I am filling that formula here. So 20 milli means 10 to the power of minus 3 here. K1 is 2, K3 is 3. So C is equal to 20 into 10 to the power of minus 3, 5 by 2. So C is equal to what? So 50 into 10 to the power of minus 3 farad. So minus 3 means millifarad. So 50 millifarad here. So what is the answer here? Answer is 50 millifarad. Okay. So we'll look at that next one here. So today just I will solve that capacitance. So in case of capacitance, we will solve the numericals related to capacitance of a parallel plate capacitor and n identical drops and all such phenomenon related to that phenomenon. Numericals we will solve in today's class, and in next class we will look at that circuit related questions related to capacitance. So let me solve that next numerical. A parallel plate condenser has initially air medium between the plates. So between the plate air medium is there. If the slab of dielectric constant K having, so dielectric constant 5 having a thickness half of the distance of separation between the plate is introduced, then percentage increase in the capacitance. So let me read out the question once again here. A parallel plate condenser has initially air medium between the plate. So initially, if it is air medium means initial capacitance, let me take it as a, so initial capacitance C1 is C0 here. If the slab of dielectric constant 5, so dielectric constant value 5 is introduced between the plate and thickness, so this dielectric medium having certain kind of thickness, having a thickness half of the distance of separation. So what about the thickness of this dielectric constant here? Half of the distance of separation. Then what about the new capacitance? What is the connecting formula for capacitance of a parallel plate capacitor if dielectric medium is introduced and the dielectric medium having that thickness T amount here? So what is the connecting formula? Can you able to remember me? So D minus of T. So D minus of T plus of T by K here. What is the connecting formula here? Epsilon naught into A divided by D minus of T plus of T by K here. So first I will fill the value. What is the thickness value they mention? D by 2 plus of, so T by K. So T is nothing but a D here. So D by 2. So K value is how much? So K value is 5 here. K value is how much? K value is 5 here. So C is equal to epsilon naught into A. So D minus of D by 2. So 2D minus of D. So that is D by 2 plus of D by 10 here. So we'll take that LCM here, epsilon naught into A divided by 20 here. So 10D, so here that 10D plus of, so this is 2 times of D here. C is equal to epsilon naught into A divided by 12D divided by 20 here. So C is equal to what? 5 epsilon naught into A divided by 3 times of D here. What is the value here? 5 by 3 epsilon naught into A divided by D. 5 by 3, let me write that epsilon naught into A divided by D is nothing but a C naught here. So shall I write it as a C naught here? So C by C naught is equal to what? 5 by 3. So they asked determine capacitance in terms of ratio here. C by C naught minus of 1. So that is 5 by 3 minus of 1 here. C by C naught divided by C naught. So that is equal to what? So 5 minus of 3. So that is 2 by 3 here. In terms of ratio here. So if you calculate that in terms of ratio, C by C naught, C minus of C naught divided by C naught is equal to 2 by 3. Percentage means into 100. So if you calculate that value here, so nearly around about that value is 66 percentage. So calculate the values. So that value will be 66.7 percentage. So C minus of C naught divided by C naught. So in terms of percentage here, so that is 66.7 percentage we will get it here. And next we'll look at that another numericals related to capacitance here. Two identical condensers M and N connected in series with a battery. So two identical condenser connected in series here. For example, this is M and this is N here. So two identical condensers are connected in series with a battery. The space between the plate M is completely filled with the dielectric medium of constant K is 8 here. So between that first plate, between that plate M here, they are introducing a dielectric constant. Its value is 8 here. So its value is 8 here. 8, and a copper plate of thickness D by 2 is introduced between the plate of N here. So in this plate, so copper plate is introduced, though that distance is, so new distance becomes as a D by 2 here, introduced between the plate N here. Then potential of M and N are respectively. So which thing I need to determine here? Potential of M and N respectively. So look at here, in order to determine that potential value, so here that a dielectric medium is introduced, here distance is decreased, so indirectly they given capacitance value. Then what is the relation between capacitance and potential here? C is equal to what? Q by V. So potential is inversely proportional to capacitance. It means what? V of M by V of N is equal to what? C of N divided by C of M. So first let me find out that capacitance in case of plate M and capacitance in case of plate M here, N here. So C is equal to what? C naught into K here. So C naught into K means, so for example C naught or C, K is nothing but what? 8. So in case of that plate M, 8C here. So what that capacitance of that plate M here, 8C. So similarly capacitance of that plate N here. So they introduce a dielectric medium value, copper value, its thickness is or distance between them is half dimension, so d by 2. So if it is d by 2 means, so shall I write it as a epsilon naught A divided by d by 2 here. C of N is equal to 2 epsilon naught A divided by d here. So then what about the capacitance? You will get it here. So C of N is equal to 2 times of C here. So I got that capacitance of plate M and as well as capacitance of plate N here. So V of M divided by V of N is equal to what? C of N divided by C of M. Why? Because capacitance and potential are inversely proportional. C of N is how much? So 2 coulomb, so that is capacitance or in terms of microfarad. So 2C you can consider. So here this one is 8C and 1:4 here. So don't get confused here. So I spell out in wrong way. So here that capacitance 8 times of the initial capacitance, here 2 times of the initial capacitance. So what is the ratio? I will get it here. So potential in terms of ratio is 1:4 here. What is the ratio? So ratio is 1:4 here.